session. This is the second session in which we are going to cover uh, machine learning on Kubernetes. So, though we kind of touched upon all of these things which we should be covering. So I did not get any further comments. I assume that this looks okay to everyone. Do I get some thumbs up from one of the author of the CNAI white paper? So I believe, I think he thinks that it's on the uh, right direction, I believe. Um, so now, of course, as we have to kind of try to go over with few things, right? So I was experimenting with a bit of Jupyter books, some machine learnings, and so on. So, but of course, this particular, and I mean, the machine learning is something which is completely kind of a same new and then interesting, but there is a lot of stuff to cover in that. So it's kind of another sea where we can dig deep as much we want, right? And it won't end kind of a thing, right? But anyway, so what I could do is I could play around a bit with Jupyter notebooks. I could install this Jupyter Hub on the Kubernetes cluster, and through which I could spin up a Jupyter notebook and could run a very simple model which I have got from the internet again by searching. But yeah, it was pretty straightforward, so which I think is a good start, which I'll share with you guys. Um, so with respect to Jupyter notebooks and Jupyter Hub, just want to kind of hear from you guys. Have you guys used Jupyter notebooks earlier? Anybody who have used? Please put on the chat or just share your experience here. Anyone else have tried Jupyter notebooks, or do you know what are they in general? You can use in VS Code. Okay. Okay. What else? Anybody else? Okay, Jupyter notebooks, nothing but you can think of in a simpler way is an interactive Python interface. We can say that. So with Jupyter notebooks, we can get a very interactive environment. Can you please mute Abdul, I believe? Yeah, so with the Jupyter notebooks, we can interact with the Python interpreter, and then perform things in a way which is very interactive. The interesting thing about Jupyter Notebook is you can assign the compute to it as you would wish. So what I could read a bit, though I have not tried myself yet, but it's think about is you can pre-populate or pre-set up the environment what is required by data science team. So for example, you can say that okay, I want to have a notebook setup in which people can get 4 GB of RAM, one GPU, and some amount of CPU, whatever is required. So you can set up all of these things beforehand. Then you can set up some of the required libraries, what are required for the data science team. So you can pre kind of populate them and then make the instance available. So what can happen in a simpler way is if data science team comes to some kind of an interface, they have multiple options. Like for example, there is one Jupyter notebook for doing the training. Other Jupyter notebook can be for inferencing and something like that, right? So you can have different versions of notebooks available, and then you can choose for this particular project. I want to have this kind of a interface or this kind of a compute environment. So when somebody initiates the given notebook, it would come with preloaded libraries, preloaded modules, or maybe data set as well, and so on. So that way, it can become very useful for data science team when they kind of do any kind of model building and so on. And we can also kind of bring down, stop these Jupyter notebooks at our own wish. So, for example, if a developer working on a Jupyter notebook, they can kind of stop it and they can restart again from the same step where we left up and all that stuff. So that way it can become very useful so that when the when your team is working, they can start the notebook when they finish the work, or they just want to save the state of it, they can do that. And of course, with Kubernetes, you can auto scale up, scale down as well. So think about, you are configuring this pre-installed setup, and you have put down on a Kubernetes cluster, and you want to give the interface to your audience. They can click, the interface comes, they do their work, and they finish off. And then, of course, as you auto scaling as available in Kubernetes, right? You can scale up during the daytime, and when there's nothing, you can scale down. But of course, some of the notebooks you may not want to shut down, so you can put some kind of a note. No, this notebook need to run continuously and all that stuff. Things you can do. Any questions so far? Okay. So with that, I'll quickly tell you how would I have installed it. So Jupyter Notebook installation is pretty straightforward actually on Kubernetes. So there is a complete documentation available. Let me show you. Jupyter uh, notebooks. Jupyter Hub actually, I believe. Yeah, so there is a site called 02 Jupyter Hub with Kubernetes. This kind of covers everything, whatever is required to kind of set up Jupyter notebooks. So Jupyter Hub is nothing but like a combination of, or kind of as a provider in a way. So you can see Jupyter Notebook is an entity which people can use, but Jupyter Hub is kind of give you more features, which I'll kind of quickly show it to you in a minute. Let me show you. So what I have done is I have followed the steps from here, and also we have quickly documented the how did we install. So we have used Docker Desktop, and the Docker Desktop I could set up the Jupyter Notebook on the local system which I have. So I can basically kind of put down this notebook on the what do you call, say, the load balancer, which is localhost, and that can serve. So if you are interested, you can kind of follow the steps, or it's available on the site as well. So I don't know why it takes so much time. Let's see. Okay, let me get it from, yeah. So wow, something happened to the site. Fine. Okay, I'll put on the chat here. This kind of no, should be okay. As you open this link, I hope it opens at your end. I don't know what happened, but it kind of covers the steps what is already given here on the side which I mentioned. So you need to kind of set up Kubernetes, of course. Then you have this Helm chart. So I'll not go over in too much about Kubernetes and Helm charts per se, because we all know that how to use Helm. I believe so. If not, that's a separate discussion altogether. So what's happening here is there is a Helm chart available for Jupyter Hub, which you can quickly install on your KTS cluster. And once that has been installed, you can initialize the Helm chart with the respective configuration. Um, so like as you can see here, what we have done here is we have run this command. We have given a name to the release name, whatever you want to give. The Jupyter Notebook Helm chart, the namespace name, and the config file. So config file is nothing but your Kubernetes Helm values.yml, which you can get and then modify accordingly. This is what it has been kind of mentioned here. We just kind of modified with the respective namespace name, that's the install name and all that stuff. So you can kind of install Jupyter Notebook with this. And this is going to by default use the some sort of type load balancer. And with Docker Desktop, what happens is your local host, your node, basically, or the same system on which you're running, that becomes the load balancer type. So as you can see that as I I access the local host, it is actually accessing, let me see if I can show you the Kubernetes part as well. 1 minute. Yeah. So this is what I'm running on my local system. And if I look at the namespace, you can see that we have a namespace called Jupyter Hub. And if I look at Helm list, sorry, I think that's a command, right? Yeah. So you can see that I have installed the Jupyter Hub Helm chart. And what this does is it's going to create a pod for every user of us. So what's happening here is, let's say if you have multiple users and if they access this particular endpoint, right, the Kubernetes is going to create a pod for every instance. And that is how you're going to have an access of this running environment. Yeah, this one, right? So we basically install this um, the Jupyter Hub on Kubernetes, and then basically you basically allow. So currently there is no authenticity configured by default, but as a part of setting up in production, you would set up the right authentication mechanism, which is pretty straightforward. So what we can do quickly here is we can quickly see the values.yml file here. Let's see. So this is the version, not this one. Oh, it's downloading. Where is the GitHub for that? There's one link given here for the configuration. Written, I don't know where it is. Let's just quickly figure out. This one, I believe. Here's something with no GitHub. Yeah, something here. Yeah. So there you go. But where is the file? Okay. Anyway, if it is not there, what we can quickly do is we can do helm fetch. Should be done. Okay, helm repo list. So what we can do is we will do helm fetch. Yeah, it's there. Quickly untar this. Yeah, so here we can find the values.yml, and this values.yml is going to help us. Okay. Okay. Let me just open this file. Mhm. 1 minute. Yeah. So this is the YML file for the Helm chart, right? So we can look at some of the information from here. Of course, I'll not go over all that stuff, but let's look at some of the information which would be useful. So let's see. Yeah, so this proxy is nothing but your endpoint through which you're going to access. This is the type load balancer type. That's what we can see here. Then, yeah, this is, I think, This is the configuration, which is saying that, 1 minute, on this one, maybe scheduling. I believe this is the one only. So single user one, and this basically what image you want to give to the end user. So for example, we discussed that, right? It is going to create a pod when a user is going to trigger the notebook, right? So it's going to pick up this image. I'm not sure what's given the name, but that's okay. Maybe that's the part. Then you can see that here we can specify the user ID and all that stuff. And then the important part here, okay, this is the one actually. This is the image. What that image was for? That was single user network tools. Something is there. What is that is okay. Okay, so values are normal first. We don't bother too much about it because it would eventually convert it into a Kubernetes manifest. So that's okay. This is the image. So this is the image is being used to basically set up the instance. Then you can see here, we can set up the resource constraint here, CPU, memory, and all those things. So what's going to happen by default is when we are going to install this particular Jupyter Hub Helm chart, we are saying that when a user is coming up, give that user a pod from this particular image of this version, and it is going to have 1 GB of CPU and memory, whatever is mentioned here. So now you can understand here, if I update this image, I can have my user to instantiate a given environment. So for example, if you know that, okay, while kind of creating the Jupyter notebook instance, I want to make sure that my user has so and so forth, whatever, so and so modules or so and so configuration. So if you look at the Docker file and modify Docker file accordingly and make a new image for that, right? So whenever they're going to spin up the notebook, they would get those kind of settings. Hope it makes sense, right? Clear? Yeah, please guys say thumbs up, yes, no, I don't know. Make sense?
Yes, I think it's clear.
Okay, great. So that is how the overall working of Jupyter Hub Helm chart. So you can play around with this. You can upgrade the chart and see here the resources, see the change image and all that stuff. So you can play around with that, and then you can have your own custom image through which the instance can come up for the notebook. So if you follow the steps here, either from here or what we have put on the link, which I mentioned, you can follow any of the steps. And with that, you would be able to install a notebook, sorry, a Jupyter Hub, and then you can access on localhost the way I'm doing it. And for the first time you log in, it's going to ask for some temporary username password, which is again not mentioned via the like it doesn't have like it's like it's a guest user, like in a way. But what it also gives you a way to kind of configure the Jupyter Hub with the real username and so on. So basically, you can configure OAuth settings, you can configure third-party login methods and all that stuff. So if you look at the Helm chart, you can find out how would you modify that. So I'll not touch upon that, but idea is that you can set up this Jupyter Hub as a self-service platform to your end user, to your company's end user, data science or whomsoever, by connecting with your own authentication mechanism. That's one. And of course, you can modify what image they would get by default as they trigger the notebook, right? Yeah. Okay. So now let's come to the part here. So what I would say is once they have the interface, this is the interface of a Jupyter Hub. And here is the notebook. And I have some notebooks already which is already in place here, but I can click on this notebook here, new notebook, right? I can of course give a name and all that thing as well. So now here, what I can do is I can interact with the notebook. Think about interactive Python. So I believe if I say a is equal to 5, 4, and then I can say run. and then I say print A, for example, or just say A. I can say run. So you can say here, I mean, just like a simple one, right? So I could now interact with the interface here. So what is happening is you call all of these things as a cell. This is a cell here. Now, in each of the cell, you can perform different things. Now, what are different things? You can see here code. So currently, if this is a code which I'm writing a code here. But if I say it's a markdown, and if I say, let's say, mm, demo session, whatever, right? And I can then run it. So you can see here it kind of becomes like a markdown stuff. So you can kind of write down what you want, and then again it kind of goes back to the code. So now the way you run it is, let's say again if I say a is equal to whatever. Okay, so a, if I use a shortcut, so okay, what happens is if I am in a given cell, if I want to come out of it, so I can press escape and I'll be out of cell, like a similar to our Vim. And then if I kind of want to do few things, for example, if I want to add new cell, I can just press A. It's going to give me a shortcut. I can write more cells, but if I kind of go inside and if I again write something, I can write A here. So you need to kind of come out of it to get the escape mode, or you can say whatever the command mode in a way. Right. Similarly, if I am again in the escape mode, I can press delete to kind of remove a given cell, like a similar to Vim, right? And then I can use J and K as I was using J and H, I believe, right? No, what is it in the thing? In Vim, J and K. Yeah. So J and K, I can go up and down. That is one thing you can do. Then let's say whatever you have written, for example, if I write here A is equal to A plus 5. So now I have previously have a value. So now I can execute it. So for execution, I can say this button here, which would execute, or I can use command in the Mac, command enter will also execute. Both you can do command enter or press this button of execution, and then I can say A. So you can say here, okay, again I have to again execute. So you can say it is A is equal to, okay, I don't know why it's on 40. I don't know. A is equal to A plus 5. Why it is 14, I don't know. That's okay. Something, just see. Okay, I think I pressed execution twice. That's why maybe. Okay, understood. But I did not print it, but I pressed this execute twice, and that is why it has become the 14 there, right? So anyway, so you can add a new cell from here. You can add a new cell plus button. You can remove a cell from here, copy. Then you can change the order of it. Like as you can see, I can make this cell go up and down as I would wish. And what else I could figure out? Yeah, you can save it. So you can save this interactive Python notebook. That is why this IPYNB, so interactive Python notebook. That is how it is being thing. You can write a name here and then save it as well. And you can download as well, I believe. So if I say file download, right? No, so yeah, allow. But there are other ways of doing it as well. I think something I'm missing here. Okay. Okay, I'll see. Anything here? Make sense? So you can quickly try it out if you want to quickly do it along with me. Maybe you can search of online Python notebooks. Okay. I think Google Colab is one of the example of it. So you can use Google Colab, or you can think about yeah. So you can say try Jupyter, and then maybe you can say Jupyter Lab, Jupyter Notebook. It may give you a running instance of it. As you can see, it is there, right? So this has already been set up. I think they already have an example which I did not see earlier. But you can see here there are these things, and you can actually write or do experiment in this. Whatever I'm doing, you can try it with here. So just say online Jupyter Notebook, and you would kind of come here, and then you can kind of play with it as what I'm doing right now. Yeah. if you wish. Okay, fine. Any questions? Have you guys tried this thing earlier? This is new to me, but anybody has tried it earlier in the class, in this session? Okay.
Hi, this is Jack Kozik. I've used Jupyter Notebook before. It's how you use Python. It's how you do the AI stuff with OpenAI. I just didn't know it was available on Kubernetes. It never even occurred to me. Thank you for showing. Thank you for sharing.
Okay, great. Yeah, so this is so what with Jupyter Notebooks we can do is we are going to play around. It's a playground for us to build our model, try out model, and so on. But of course, you cannot just take a Python notebook and say deploy as a model on your GPUs and all that stuff. There's more work to be involved, but we'll see it as we kind of go. Today, we just look at how we can play around with our notebooks and build and try a very simple model, which I'll show you in a minute. Okay, great. So I believe you all experiment with me. I'll just give you, I think that would be useful actually if you guys can do it. Just search for
Oh, can I
online.
ask one more question before you
Yeah,
change subject?
sure.
Have you talked about how the 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 how storage is managed? You showed a Helm chart, and I just missed the.
Yeah, so
You had a
storage
big
is,
value
yeah,
screen.
yeah, yeah. So
You need to have a
storage,
separate storage. You need
yeah,
to have
yeah.
a
So it's
separate
a
storage,
PV
right?
and the PVC. So again, in the values.ymfile, you can see here, this is in that particular part, it is given as 10 GB by default storage. So you get PV and the PVC. So as we can see here, uh, it would be there somewhere. Quickly, I'll show you. Yeah, this one, right? So you can see here, right?
So you just do a normal persistent volume claim. It's
Yeah, correct.
all
Yes,
normal. It's
all there.
all
So
in the, okay. Okay.
if I look at here in my case,
Okay. Okay.
you see
Okay.
here,
Thank you.
look at
Thank you.
PVC minus N. What's the namespace name? Jupyter Hub. So you can see here, it would be assigned this to me, right?
Okay. That works.
So that is how it is going to be done.
Thank you.
Okay, great. So yeah, so the idea is that you can set up Jupyter Hub on your Kubernetes cluster, have your developers come. You can put the authentication in front of it. As they log in, they can click a button. They'll get an interface. They'll get an option. So, for example, what I was showing you here, right, in the home, right, like I believe not here, where it is. Yeah. So I believe what's going to happen is you're going to have different notebook listed here, maybe for by the project, for example, and as they click on it, the respective notebook would trigger and so on and so forth. That is how it is. It is going to kind of it is going to come live, right? So yeah, and of course, with this Jupyter Hub, you can also get access to a terminal. Then you can also kind of um, try out a text file, build a markdown, build a Python file, and other stuff. So you can do all of these things by just staying in this interface. This is one way of how you can do it. But just I come across one more thing. As a developer, if I'm just working on my local environment, right? So now why this particular notebook can become very handy for developers and for example, for the larger companies, right? See, developer would always going to have less number of resources on the laptop. Okay, of course, they'll not have a GPU like the way we just saw that, right? Abdul was saying that I don't have a GPU to work on my local laptop. But if this notebook is being served by some third party like a Kubernetes cluster, which is having access to the cluster, the resources and so on, then we can allow the GPU based notebooks as well. Correct. Um, what I call also figured out or not figured out per se, I was seeing that a product called Anaconda. This Anaconda is a software which you can install on a local laptop, and then it is also being used by the data science team, and then they can get access to Jupyter Notebook. They can get access to I don't know some other stuff there. So this Anaconda seems to be very popular in the data science community. and this kind of help you in doing a lot of things. But again, this is going to work only on the laptop, I assume so, unless there is a hosted model. But what I was saying with the Kubernetes based thing, that you can give resources, or the developer would not be kind of say dependent on the local setup. Okay. Okay, so this is what about Jupyter Hub and Jupyter Notebooks. Hope you got some idea about it, right? Now, what we'll be doing is we'll be kind of trying to look at what are models, and with those models, how we can just try out a very simple model on the Jupyter Notebook today. So there are, what I could read is there are a few different types of machine learning models or machine learning things we can do, like supervised learning, unsupervised learning, and reinforcement learning. Anyone knows what are these things? Supervised learning and unsupervised learning and reinforcement learning. Anyone has any idea on that? On those? Or what do you mean? Even if you don't know, what can you infer from the name supervised learning? What does it infer for you? Anyone? Come on, guys. Come on, try.
Okay, so I'm assuming you're talking about the the embedding process
No.
and
That's way too advanced.
oh, okay.
Supervised learning. So I'm saying, so there are two different things are there. One is you are building a model, and then you would use those models to refer the new data. That is when embedding all those things would come into picture. So we are a layer below than the inferencing right now. And reinforcement learning. Okay. So let's see. Supervised learning again. I'm also just kind of learned it a bit, but I think I'll cover it a bit more detail in the next time if I kind of get more time. So supervised learning in a simple thing, right? If you look at uh, you kind of in a way that you know a pattern, and then when a new data is being given to you, you can see that okay whether where this data would fit in my environment. So think about again the example what we have is that think about if you know that at your own location what are the property prices, right? So you know that, right? Okay, if there is a two-bedroom apartment, it is going to cost or whatever number of amount of dollars. If it is going to be three-room house, it's going to cost X amount. Any kind of collect the data of the entire locality of yours, and then somebody comes, okay, I want to now buy let's say 5-bedroom apartment or whatever. So by looking at the data you can see that okay, this is going to come in this range kind of a thing, right? That is in a way of supervised learning, right? You know the kind of a, say um, the range and overall things, and then you can come and predict, right? Unsupervised learning, as the name suggests, right? We are not going to give you a pattern ahead of time, like or whatever that graph, right? Okay, this cost this much and all those things. It is going to look at the data and then classify them. So, for example, is even though there are two-bedroom apartment, but some of them would cost high depending on the locality you are in, right? So, for example, I believe in every city there are some localities which are very expensive, right? So now what can happen is you give this data to you kind of just write down this data into a Excel sheet, and then uh, by yourself, right, or by this in this case machine learning, right, can classify them, right? You don't, it will not tell you which locality, but it can tell you okay, these kind of apartments are at a higher cost, and then you can kind of say that okay, this may be of this locality kind of a thing, right? So in this case, I am not giving my ML to kind of um, a kind of pre-information, right? It need to be figured out on its own. So classification is a example of unsupervised learning. Make sense? And
Okay.
what is reinforcement learning? It is okay. So somebody's writing, sorry, I'm not seeing that. Sorry about that. Okay. Reinforcement learning is like the way we learn as a human. We learn as the kids learn, right? They, for example, if they touch any hot thing, next time will not touch the hot thing because they know that okay, if I touch it, I'm going to get I'm going to burn my hand in a way, right? That is how this particular last reinforcement learning works, where you learn by experience, by doing things, and that is how the robots and whatever people are building, it's going to run, right? Because you leave something open, like the way we leave ourselves open or our kids open in a playground or whatever, right? By observing, by trying out things, we learn. And then what happens is, if I do right thing, I'll get reward. If I don't do the right thing, I'll get punishment, for example, right? And that way we know that okay, doing this thing would be better for me. And that is how the entire machine learning AI thing works, that you leave something on the open, they kind of go try out few things, and if it is positive, they get the reward. And then that's how the weight of something will increase, right? So for example, if you all know, right, eating whatever, I don't know, protein would good as is good for our muscles, right, in a way, right? So we'll try to kind of see that okay, if this food has protein, we'll just kind of go and eat it, and something like that, right? That is how the reinforcement learning is being there. This is a very high level thing. I am not an expert, but I'll try to kind of see if I can come with more example next time. And I kind of happy if you also kind of go back and read about all these three things and share your example as well, right? What are these different kind of machine learning ways of doing things? This is really going to open up a lot of understanding what is happening behind the scene with the LLMs and all that stuff, right? So I highly encourage that you kind of go and read these three things, and we'll discuss next time. Okay. Okay. So with that, we'll look at a very simple example, which I was telling. So again, this is not done by me. I kind of found out. I found out something on the Git repo because I was looking for something very simple, which we can kind of understand, and then try to build our model and then test it as well. Now, this particular data again is kind of an old IPython lab, so if something did not work, but still it's kind of give us what we're looking for right now. So here, what they're saying is, I'm going to kind of predict the price of the house. So the same thing are saying that, right? If I know the cost, if I know the cost of a given area, for example, in this case, right, we are saying that okay, if the size of the house is 300 square feet, this is the actual cost in the thousands multiple of USDs, right? This is how it is. So now, of course, you have this kind of a CSV file, but of course, we can load it into a simple Python object. So now what we're doing is we're creating two variables here, X and Y, and we are kind of putting the content of that in a row and the whatever we have, right, in the two columns there. Let's be run this thing. So wherever I have, I'll give this link to you guys also if you want to kind of just copy along on the chat. So if you just have a sample Python notebook somewhere, you can try it along with me. So now what I'll be doing is I'll just kind of put in these two variables. So where is my empty one? It's here, right? So I'll just start this new, and I'm just going to say two variables. So now again, this is in the cell. To execute, I can say simply shift or command enter. It would kind of do that stuff. No, sorry, command enter, right? Yeah, yeah. Okay, I can just quickly add here. So once I've just given my variable names, I'm good. Now the next step is what I can do is I'm just going to use this matplotlib to plot it in a as a graph of it, right? So I'll just do that. Yeah. So if you don't have if this is the first time you're doing it, what may happen is you may need to install this particular module. So this module is already there with me. If it is not there, you can simply do pip install and the given module what I'm looking for. So what is a pip? Pip is nothing but a package manager for Python, and that is how we install a given module. So if you are new, you can quickly install it, or if it's not there for you, you can just install this with the pip install and a given module name. So once I have done that, what I'm doing here is matplotlib is nothing but something to draw our whatever diagrams and all those things, right? So now what I'm doing is I'm saying that create a kind of a say a graph for me, as I'm setting a certain title, X label and Y label, as you can see here, right? So I'm putting up a the kind of a title of my graph. This is the price. This is the size. Correct. This is how it is being done. And then, other than grid and all stuff, I'll just ignore it for now. Now, what I'm going to do is I'm going to use this um, uh, sklearn or sklearn, what they call it, right? So what we are doing is we are trying to get this linear regression uh, model to kind of to fit in this particular data. So what you can see here in this particular um, output, what we have seen, right? They kind of fall under like a think about they're kind of in a linear line in a way, right? They're not kind of everywhere. So we can use this linear regression model or the ML model, one of the model, to kind of plot the kind of a say. Let me just do that and show you 1 minute. So I just again copy stuff. So I'm just saying that so you can see here. What I'm doing is I'm from the sklearn. I'm getting the linear regression model, which is a type of supervised learning. So I know that what I'm doing here is I already have existing data. From there, I want to predict. So I look at my current data, what I have, find the pattern, and I can predict the cost of the next house, which is about to be sold. Correct? This is an example of supervised learning, and that is where I can use this particular model. So that is why it is important to understand what kind of model we need to use in what situation. So I think that is very important as far as I can get it. So from my limited knowledge for now. But yeah, anyway. So now what I'll do is I'm just going to add a new cell here, and then specify this. I want to get this model, linear regression model. I'm going to get that. Would execute it. So it's kind of in place now. Now what I'll be doing is I'm going to, again, as the example says, what we can do is we're going to plot one more time here. But as you can see here, we're having one more extra line here, which is saying model predict X, sorry. So we are saying it, try to, have this model, and I'm saying that take that model and try to match it with the X data what I have here. So based on that, it is going to generate this particular information for us. So as you can see, something is wrong. What's wrong? What is wrong? What do you see here? Okay, so I need to do a fit. Okay, so I skipped one step here. So what I'm going to do is I'm going to say model fit X and Y. So whatever the data I have here, right? This X and Y thing, right? I have X and Y object of Python. So I'm going to say that, okay, now use this particular data set, what I have X and Y, and try to fit with this particular model, right? So I have, this is the model, which is the supervised learning based model. I'm saying that look at my data and try to get a model for me. So this is actually trying to map that model. So if I run this command, that's what says that, right? You should fit it first, right? That I did not do earlier. So let me kind of go and do a new cell creation, and then I'll say a model fit. So now it has been fitted with the data what I have, and then I can, what I can do, I can quickly get this cell. I can say go down after that, and then redo it again. So now you can see here, it is now creating a line which is kind of fitting my data set. So I have not done anything myself, right? So this particular model, which is already part of that library, right? That looked at my data and try to fit what is the best fit here. Now, why would so basically try to put the line at the right place. It's not put the line above, bottom, and so on. It is saying what is the ideal place or how this particular data set fit right in a given model. That is what it's saying here. Hope it makes sense. Any questions here? Does it make sense or no? Is it too much, too less?
I'm sorry. It works for me. I'm starting to download this, and I'm trying to follow along on my own
Okay.
Jupyter notebook. So this is good.
Okay. Anybody else? Any other comments? See, in general, what we have to do is we have to find a pattern in this particular case. And once we find the pattern, we can predict the next value, correct? That is what we're trying to achieve here, right? So now, what we'll do next is, so the next step is, yeah, so there is some, what do you call, say, typos here and all, not typos. This is done with the older version of Python, so it did not work as we kind of mentioned here, but I'm just going to use this function for now and then tell you what the function does actually. And that will suffice for us actually in a way. It should be written below it. Yeah. What I'm defining here is I'm defining a function here, which is house price predict. So what I'm saying is if I give you a size, tell me what is the price of it, as simple as that, nothing much, correct? Or we can simplify it actually, we can simply keep this as well. So now what we can do is we can simply say model size predict, and if I say let's say 250, which is not in my current list, as you can see here, I don't have a price of the 250 square feet house, right? So if I say here 250 square feet, sorry, it should give me a data. It should be $124,000. I could not add and multiply it, but it would come somewhere here. So it is 124K. This is for 500 square feet. No, this is the price, right? This is the square feet house, right? So it is somewhere here, and it is saying 124. 300 was 80. Uh, I don't know. Okay, this may kind of, okay. So the one more, I'll talk about that point in a minute. But what we got, let me just try to do exactly what we have. Let me just try one more time of a different size. Let's say $350, 350 square feet. Now it's 142. So for example, you can see a 350 is somewhere here, and it's coming between, of course, 100 to 200. Similarly, let's say if I do 200 square feet. So you can see it's kind of getting some price in the range, right? So this is how a simple model works, right? So you have found a pattern and you will try to match against this line. Basically, this is the line. So basically this, if you expand this line to both down and up, right, that becomes your model. And against that, you're going to get the price of a given house. Make sense? Okay, now there's one more point to note here is, see, this is, if you look at, this is the data which is more or less on the line, while this is a bit far, correct? This is called as an error. So what happened here is we have created a model, and that model is giving us what is the best fit it can find. And now, if the point is very near to the given linear line, what you can see, it has a low error, but this has a higher error. but this is the best pattern what we can create with the data what we have at this point of time. Correct? And that is why, as we kind of, okay, so I think I'll not touch upon that point. But any questions here? At a high level, that makes sense or not? At a very high level. Again, as we are not data scientists, to be honest, so we just need to kind of look at very high level and understand what is happening. Is it still makes sense?
Right.
Yeah,
To me, this is following regression analysis like we learned in school.
Yeah, correct, of course.
Yeah.
it's just showing the power of using a pre-existing model, right? I mean, the speed with which you're able to produce this, in the space of a session here today is, obviously very powerful.
Yeah, thank you. Yeah. So now, so what we have, we just saw an example of a very simple model creation, and then we saw that if I give an input to it, it can tell us what is the next value to it. There's one more version of it is being given. So now let's look at here whether this particular model, how to evaluate the given model per se, right? So what happened here is there is an extra column right now, which was not there earlier. So let me kind of go back here. So earlier the size was given and actual price was given. Now what happened is we built our model, right? And then what we are doing is we are doing a prediction, correct? So we saw that for the 250 square feet, it is 124K USD. That's what we saw also. That if I put 250 square feet, we could get 124K USD for the given house. But if I look at the actual data which was from the field, it is this one, $100. Correct? So now I have done the prediction, and you can see here, by doing this, I would basically be in a loss in a way. So for example, if I'm a real estate company, I use this model and saying that with the prediction for 250 square feet, I should be whatever selling it at 124, and I kind of do that, but actually I would be selling it $120 only, correct? So this is how the model can misbehave in a way, right? If it has not been trained rightly with the right parameters, so currently we may look at only one parameter, but what if the new parameter would have come? Let's say if this particular property is now uh, basically, I don't know, having some negative whatever, let's say um, has a high chance of getting tornado. I'm just putting up something, right? Of course, that will reduce the price, right? And we have not taken account that particular value now. So this model may have been built maybe 2 years back, but now because of the new variable or new condition, which we have not taken into account, I am basically predicting the older values, but the real values are these ones, correct? And that is why we have to retrain the model with the new parameters what we get, right? Hope it makes sense, right? You cannot use the model for forever time, right? You need to update the model based on the condition. So if I don't try to reduce this particular prediction and the actual cost, I would be not having the right model which I have been building. Make sense? Yeah. I think that's all I would want to kind of cover. Any questions here?
No, but it is, I think, nice how you presented, because at the beginning I was hesitating why we are using a regression line, but you ended up all your points saying, okay, this is the prediction. The prediction is not accurate with the real world, which is something that is covered in the chapter in the second chapter. So maybe the decision is to change the model, or just to add more parameters to the model in order that the prediction of the model match or fit with the reality. So I like at the end of your point. At the beginning, it was a little bit lost, but then you ended in a nice way.
Is this an example of reinforced though? Because we've made some observations here to improve our model. So
no, but we are doing it. We are doing it ourselves, right? It should be done automatically, right? So model should learn on its own, right? Like for example, I mean the example what you can think of somebody like the way they publish some game, there a football game, right? I don't know which. I think IBM or somebody, right? They basically made a robot, and that robot can basically live on the field, right? They just left on the field, and then they learn that okay, if I play the football by this particular speed, it should go in the goal, kind of a thing, whatever, right? That would happen automatically. I'm not putting something in front of the ML or AI what is there, right? It is doing the things and then making the change on its own. So it will kind of learn on its own. I think we'll see the example of it later, right?
Yeah,
But
yeah.
this is not an example of info. It's not for sure. It should do automatically rather than we telling us.
Yeah, you're just updating the data set, obviously.
Yeah, correct. Yes.
Cool.
Yeah. Okay. So for the next time, so again, this is what we did right now, a model in the Jupyter notebook. But of course, you cannot put this model in the MLOps pipeline, right? So like today you have 1,000 data sets, right? Tomorrow you may get, okay, so you build a model and that model is, we saw that, right? It is kind of going to be not so good for us, right? So we need to kind of build a new version of it with any other parameter, let's say weather or whatever it is, right? And that is how we need to continuously keep building the model and make it run the production and all those things, right? So we cannot take this Jupyter notebook and say run in the production, right? There has to be a way by which we can package this model and then try to ship it and continue to ship it and so on and so forth. That is what the entire MLOps is. So I'll try to maybe come up with a few more examples of this, different kind of learnings, and see how we can understand the types of machine learning, a very very high level, and then we dive into how we can build a model with parameterization, so that that particular model can take different inputs. Like currently, this is a hard code stuff, right? What if I want to add a different data set and then see what happens, kind of a say, right? So you cannot hard code this thing every time. So all of those things would come in the entire MLOps pipeline. So yeah, I highly encourage kind of you also spend some time in doing more research and then try it. At least if you can go back and look at the example of supervised learning, unsupervised learning, and reinforcement learning, come back with an example. We discuss on that and then continue forward. Yeah. Okay. Any other questions? Otherwise, we are good for today.
So I downloaded the whole ML demo. I cloned it, and I think the regression section. If it's like the regression section, I want to do the other sections.
Yeah, we should. I mean, you can try it out, of course.
I'm going to do the classification. Just to see what
Yeah.
what functions are being pulled in. It's all perfectly reasonable. It's just not things I'm familiar with, and
Yeah.
so it's good. It's good for learning. Thank you.
Yeah, please. And then, of course, if you do it, you can also share it in the next time. If that's okay for you, you can take a lead on this. And then, if you want to share your experiments, what you're doing with us, that would be helpful.
Oh no, yeah, maybe, but don't put me on the agenda because I don't have control over my time on Thursdays. But yeah, this is all very interesting learning. At some point, this builds up into doing the machine learning exercises where you start using the Open API, the Open AI API.
Mhm.
And so I find that fascinating. So thus things like embeddings and retrieval augmented generation
So
are.
this is a pre-step of this is
Oh yes, I
basically we can
understand.
say that this is how the model is being built. This is how the what you say LLMs are being built, right? This is what
Yes,
how they're being built, and this is what it is about. I think more advanced of that, but this is the backstage of that, right? And then
yes, and I
what you do
appreciate it.
on top, so that will be to that.
It's very nice of you to bring this up. Thank you. I want to make a gist of this, so this is very good.
Okay. Okay. Then see you guys. Yeah.
See
Do share your
you.
feedback. I think we need more people to participate and then kind of say be part of this learning. Yeah. Okay. Thank you guys. See you. Bye bye.
Thank you.
That's
See you
brilliant.
next
Well
time.
done.
Thank you.
Well done, NK. That's amazing.
Thank you.